Welcome to today's lesson, in which we are going to use the power series representation to evaluate if this limit exists. Let's dive in. First thing first, we have to see how our limit is. 1 plus x, open bracket, then we close, to the power 1 over x. If we plug in 0 here and 0 here, it will be 1 to the power 1 over 0, which is 1 to the power infinity, which is indeterminate. So first thing first, we can see that we need to drop down the power from there to here. So how can we drop the power? A question comes. So the first thing you should do, you can equate this whole thing to y. So we'll say y is equivalent to the limit of x as it approaches 0, 1 plus x, 1 over x as a power. Now from here, I will introduce natural log both sides. I'll introduce natural log at both sides. So we know the properties of natural log. They can drop down the power and the power would multiply with the whole function. So let's do as wise. So this would turn out, I will not write the limit now. I'll just leave it. I'll introduce it later as we go in the question. So I'll write it as 1 over x ln of 1 plus x, like this. Now in this form which it is now, we can use what? L'Hopital's rule. We can use L'Hopital's rule to find the limit. But now, let's take a cautious. They have said that we must use what? Power series representation to solve this limit. So for us now, what we need to identify is what ln of 1 plus x is in power series. There's a very simple way which we can use for us to come up with a series of ln of 1 plus x. So I'll write it here. Ln of 1 plus x is the same as, we can differentiate this. So when you differentiate ln of 1 plus x, the derivative of whatever is inside here is 1. So it is 1 over the function which is inside here, which is 1 plus x. This is the derivative of 1 plus of ln of 1 plus x. Now from here, how we can come up with a power series where we have reached here, we just have to make this what we have here identical to this mammal, which is a over, this is a over 1 minus x. If we make it into this form, we can write it now as a power series in this form, a x to the power what? To the power n. So what we just need to do is to make this function be equal to this function. So the first thing first, let's check. Do we have 1 here? We have 1 there. Okay. Our a is correspondent with 1. It's okay. Now look, we have a positive, we have a negative. So for us to have a negative, think of something like this. Positive is the same as writing negative multiplied by another negative. This will give you what? A positive. So we can separate this negative and see what we have. So our function, our top function, it would end up being like this: 1 minus, I'll say minus x to the power x negative. Now look at this. Now we have a is 1. We have 1 here, and now we have a negative. We have put our negative, it's there. And our x is now at negative x. Now see, when you have something like this, you can write it as a power series of this form. So I'll come and say, I'll write this. Now what is my a? My a is 1. I'll write it. Now what is my x? My x here is positive. I write a positive x. But look, now I have a negative x. So instead of writing x to the power n, I'll write negative x to the power n. Now I want to show you one one good thing. If I say a multiplied by b to the power n, this is the same as a to the power n, b to the power n, because I'm just distributing the power. Now, look at this, negative x to the power n. X has a coefficient of negative 1. So this is the same as just writing negative 1 to the power n, x to the power n. So let's go ahead and substitute this for negative x to the power n. So our series now will look like this. I will not write 1 because 1 doesn't do anything to the series. It does little but no effect. So this is x, this is x, this is x to the power n. Now, there's one thing which we really need to take cautious of. There's really one thing we need to take cautious of. Look at this. This series which we have found here, it is a series for 1 over 1 plus x. But we wanted to find a series for ln of 1 plus x. Now, how can you get back from here to here? You just have to integrate. You just have to integrate this function. It will give you this function. Now, if you integrate this function, what it means is, if you come and integrate its series, when you integrate the series of 1 over 1 plus x, the series that you are going to find is a series of ln of 1 plus x. So I'll come and integrate this series. So when I integrate this series, I'll write this. I'll write first negative 1 to the power n. Now, our main focus will come on what? On x. How do we integrate x to the power n? We say x to the power n, we'll add 1 to the power, isn't it? Then we'll divide by the new power. Now, ladies and gentlemen, what we have here is the series of ln of 1 plus x, as n is starting from what? Starting from 0. When n is starting from 0, this is the series we have of ln of 1 plus x. So we are going to take our series here and come and write it here, replace it there. So now, what we have, it is ln of y equal to 1 over x. Now, we are going to write our series, which we have just found. We are going to write our series, which we have just found. This boy, x n plus 1 over n plus 1. Now, look at this interesting thing. Look at this interesting thing we have. So, we are going to find at least 3 terms for our series. So, I'll write ln y equal to 1 over x. So, from here, let's ask ourselves, when we substitute 0 wherever we are seeing n, when I substitute 0 for negative 1, negative 1 to the power 0 is 1. 0 here to make this bottom to be 1. X, if I put 0 here, it will be x to the power 1. So the first term will be x. Now when I put 1, because we're moving from 0 to 1, when I put 1 for negative 1 to the power 1, it is negative 1. Then when I put 1 here where there's n for this x, this time around it will be 1 plus 1, which will equal to 2. So this will be x to the power 2. And we see that and what is in the denominator is the same. Let's do the last one. When we substitute 2 for n, when I substitute 2 there, negative 1 to the power 2 will produce a positive. When I put 2 there, 2 plus 1, it will be x to the power 3 divided by 3. Then we know that the one that is going to follow is what? Negative. We can end from here. Now, here is where an interesting part comes in. We can see that we are multiplying whatever the series as it goes to infinity with 1 over x. So when we multiply 1 over x to the series, which just these terms which you can see, we can say that ln of x is equal to, when we multiply x multiplied by 1 over x, this is 1, minus, for this guy we are going to get x divided by 2. The second one, we are going to get x squared divided by 3. And this thing is going to continue as the series progresses as well. Now remember, I said that we are going to introduce the series back, the limit back. So let's introduce it back. Let's introduce it back. So the limit as x approaches 0 positive, then this will be 1 minus x over 2 plus x squared over 3 minus going until up to infinity. Now ask yourselves, when we substitute 0, we put 0 where there is x, we can see that this term will be 0, this term will be 0. The progress, as the term progresses, they will be just becoming 0, 0, 0, because we are going to be having x terms. But look at the first one, we are only having 1. So this limit now has no effect here. This is going to just remain as 1. So this right hand side, we are just going to have, at the left hand side, it will be natural log of y equal to what? Equal to 1. Equal to 1. Now, what we really need to find, what we really want to find is what y is. What y is. So how can we find y? We can just raise both sides to be power of exponent. So this natural log and exponent will cancel. So we are going to have y equal to Euler's number, which is approximately 2 point something, 2.1413. Yeah. So we can see that y is equal to Euler's number, which is a defined number. So from here, we can conclude to say the limit for as x approaches 0, 1 plus x to the power 1 over x, it exists. It exists. Hence, shown. Thank you for watching. We hope on seeing you on the next video concerning the same topic. Bye bye.